Edge computing and big data. Processing data closer to the source. Hybrid cloud edge architectures for real-time analytics. This is the introductory slide to the concept of edge computing and its relationship with big data. What is edge computing? Edge computing is a computing paradigm that brings data processing closer to data sources, reducing latency and bandwidth usage. Key characteristics of edge computing are distributed processing, low latency responses, reduced cloud dependency, and real-time data analysis. So instead of sending all data to a central cloud for processing, edge computing distributes the processing tasks to devices or servers located closer to where the data is generated. Edge versus cloud computing. Let's compare edge computing with cloud computing. In terms of latency, edge computing provides ultra-low latency, approximately 1 to 10 milliseconds, while cloud computing has higher latency, approximately 50 to 100 milliseconds. For processing, edge computing happens locally or near the data source, whereas cloud computing uses centralized servers. Bandwidth usage is reduced in edge computing, but cloud computing requires high bandwidth. Finally, the ideal use cases for edge computing are Internet of Things and real-time applications, while cloud computing is better suited for storage and analytics. Big data at the edge. Let's explore the challenges and benefits of processing big data at the edge. The challenges include limited processing power, storage constraints, network connectivity issues, and data synchronization needs. The benefits are real-time processing capabilities, reduced data transfer requirements, enhanced privacy, and improved reliability. So, edge computing offers opportunities for processing big data closer to the source, but it also comes with its own set of challenges. Hybrid cloud edge architecture. A hybrid approach combines the strengths of both cloud and edge computing. In this architecture, the edge layer handles local processing, the fog layer provides intermediate processing, and the cloud layer is used for centralized analytics. The data flows seamlessly between these layers. The architecture benefits by enabling a seamless data flow between edge devices and cloud infrastructure for optimal performance and resource utilization. Edge data processing example. Let's look at a Python code example for edge data processing. Here's the code. Import pandas as PD from datetime import datetime, def process underscore sensor underscore data, open bracket data close bracket colon df equals pd.data frame, open bracket data close bracket filtered equals df open bracket single quote temp single quote close bracket greater than 25 close bracket, return filtered dot to underscore dict, open and close bracket end. Hash real-time processing at edge, result equals process underscore sensor underscore data open bracket sensor underscore readings close bracket. The processing steps are: collect sensor data locally, filter relevant data points, process in real time, and send the results to the cloud. This demonstrates a simplified example of how data can be processed at the edge. Use cases and applications. Edge computing has numerous applications across various sectors. In Internet of Things analytics, it enables real-time sensor data processing and anomaly detection, useful in smart manufacturing and predictive maintenance. For smart cities, it optimizes traffic and manages resources, such as traffic lights and waste management systems. In autonomous vehicles, it supports real-time decision-making and navigation for self-driving cars and drone delivery. In healthcare, it facilitates patient monitoring and emergency response through wearable devices and remote diagnostics. Future of edge computing. Let's explore the future of edge computing. Emerging trends include fifth-generation integration, artificial intelligence or machine learning at the edge, edge-native applications, and serverless edge computing. Key opportunities include enhanced user experience, cost optimization, new business models, and improved security. In conclusion, edge computing transforms big data processing by bringing intelligence closer to data sources, enabling real-time insights and efficient resource utilization. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.